Hello and welcome again. In today's video it's by special request of one of my viewers, and his question was how would you accurately position holes and machine something to very accurate standards if your milling machine doesn't have a DRO on it, and perhaps although the slides are in good working order, the lead screws are badly worn and non-linear. Or the other option, of course, is if you've got an imperial machine and you want to work in, you've only got metric measuring tools and cutters, etc. So join me behind the milling machine in a moment, and I'll discuss and show you how I'll go about doing it. Join me over at the mill in a moment. Bye. Now, I've seen some people on YouTube when they actually need to move a known distance, they tend to use one of these, what I class as a plunger dial indicator. The biggest trouble with these is it's not much good if say you want to move 4 inches, unless you buy one of these for an arm and a leg that's got 4 inches. You're a little bit stuck. And also the biggest problem with these is what they call cosine error. I mean, unless this plunger is absolutely parallel to your bed and perpendicular to the part, you won't actually get a true reading. So I don't personally. I wouldn't use one of these. So the method that I use for setting this up is that you actually need a reference to start with. So I mean, there's as an instance, this is a parallel that you can actually bolt through. Now this actually must be either clocked in or square to your table, otherwise you won't get the correct reading. And also this is for the Y direction, and you'll need another one for the X direction. And what I've actually got, I don't know whether other people have seen it, this is a little plate that I've made up that's got a bolt with a brass radius end on it, and the idea is just make sure that your T-slot is clean, and you can just drop that into the T-slot and just tweak the bolt on the back, and you've now got yourself a lovely reference on there. So that's what I shall do now. Is so I'll just set these two up to make sure that they're in position, and then I'll then demonstrate how I intend to do all this. Back in a moment. Right. So what you're seeing now is I've set the plate in the back here, and for the Y direction, and this parallel, where are we there? Yeah, this parallel is set up square again for working in the X direction. Now I must point out first off that for all this to work, you have to make sure that your head is fully trammed in. I mean, especially you've got like a Bridgeport type of thing, you really need the tilt and the nod tramming in, because otherwise any change in spindle height or table height will affect your X and Y accuracy. Now the other thing that I'm used, so I've got it in view is just a standard half thou DTI. Now, before people make a comment, it's not going to matter that the stylus down here is at any particular angle. It doesn't matter, because all that we're actually going to do is we're going to be using this as a reference. So it's just that when the stylus touches and I set the dial to 0, there's no cosine error or anything going to be involved, because we're just using it as an indicator. Now the idea of it now is that I'll move the camera up a bit and show you what I intend to do with the part. Be back in a moment. Now for the this process to work nice and easily, it is better to work with your dials working in a or the handle, shall I say, in an anti-clockwise direction, because it's going to be so much easier for how the process is going to work. So for this, I need to know, because the part is sticking out the vise so high, really what I need to know is where the fixed jaw is, but on the anti-clockwise direction. So to achieve that, I'm going to do what is known as a projected surface. So the idea is you need a decent part that you can hold against it, and then we'll edge find against this part sticking on there. So as per usual, we'll just start that up. All right, we're okay, we're safe on there. Right, away we go. We need to, I've got that sticking out on there, and we just, as per usual, just carefully bring it back, just until it kicks off. Almost there, get in there, almost there. Yeah, and she's kicked off. So right. Now what you need to do now is don't move the table or anything, because what we need to do now is to shift this back half the diameter of your edge finder. Now I should be working in metric, only because this is a metric metric edge finder. So this is 10mm. So what I've actually got to do now is do a well, I can actually now just leave this as it is, and I will show you what I intend to do next. Don't go away. Right, so here we are, ready to set up these. As I say, just to remind you, the edge finder's just kicked off. So what we've actually got now is I have here a 5mm slip gauge. What you got to do is to put it up against the edge, make sure it's nice and clean. Now don't move the table. You've actually got to physically move the dial indicator in until you get a reading of whatever. As I say, I've set that to 0. So there we are, set on 0. So what you actually want to do now is to now remove the slip gauge. Carefully remove the slip gauge without knocking the DTI. Now you can actually move the table anti-clockwise until the DTI reads 0 again. And that's now put your centre line of your spindle right on the edge. Now, just so that you can come back to it at a future point, now's a good idea to set your lead screw dial to 0, which is what I've just done now. Now you just to check that, just wind it off again and back again to 0. Just check that the dial, yeah, and the dial's reading 0 again. It's irrespective of whether your lead screw's worn or the and the nuts are worn. You're bringing it back to exactly the same point, so you know it's fine. So that's the situation that we've now set up. So we actually know where we are for the Y direction. And of course you need to do the same for the X, but I'm not going to do that, as you say, because it's a lot of fiddling about. You've seen how I've done it here. It's just a case of setting it up and doing it for the X direction. Right. I'm back again. So say I now need to drill a hole 50 millimeters in from where we are. So it doesn't matter at the moment. You can just crank the table away. I now have my where are we? I've got a Joe block slip gauge again, 50 millimeters. You pop that into the same position, making sure it's nice and clean on there, and then just anti-clockwise bring the table back until the dial indicator reads 0, and there we are. You are now 50 millimeters, exactly 50 millimeters away from the back edge to where that you want to go. I'll just lift the camera up a bit and hopefully show you that, so that you believe me. There we are. I mean, although this is still a wobble, I mean, if I just straighten it up so that it's there, see, we've now 50 millimeters from there to there. So, and likewise, you can do the same for the X direction as well. Yeah. So as I said, it's a lot of fiddling about, but as I say, if you haven't got if you've got no other way of doing it, and the job's got to be right, well, you just have to bite the bullet and keep fiddling with the setup until you get it correct. Now the problems that you come up against is if you want to mill a slot of a known width, of course, that becomes a lot more difficult. I mean, it's easy to position the cutter to the centre of the slot, but of course to then actually do your plus and minus Y to get the correct width slot is quite a lot of fiddling about with these, you know, by doing it by this method. But don't know quite what else we can do. I'll have a little think. So I've been thinking about this project for quite some time, and it's not until I'm now actually trying to describe it to you that you know, of course, I'm coming up with these other problems. So bear with me, and I shall be back. Well, I've had a little think. The only option that the conclusion that I'll come to is that you'd have to use you know, say you was milling a pocket out, or a slot. I mean, if you're just milling a slot, use the previous method to actually get the cutter on the centre line, and then what you'd actually need to do is, you know, you'd have to get yourself a plunger clock and ensure you can get it as perpendicular in both directions as you can to the part, and then of course you'll be able to move your Y, you know, plus and minus to open the slot out to the right width. And likewise, of course, should you do a pocket, well, you need two of these. You'd need one there and another one on the end to give you your XY coordinates. Yeah, that seems to be the best solution that I've come up with. Now, the final bit, of course, is depth-wise. How would you set the depth of a slot? I'll show you a situation what I think is probably one of the easiest ways around it. I mean, if anybody else has got any other ideas, I mean, please feel free to leave something in the comment, and you know, I mean, we can all learn from each other's experiences. I'll set something up for the vertical position back in a moment. Before I broke the setup down, I just thought I'd show you what I've actually got. Is I've got a heavy duty mag base clamped to the knee, and as I said, and we've got all these multiple extensions and things that was actually going over to the to my fixed block. So I just thought I'd show you that before I broke it all down to give you you know, some idea of how to go about it. Right, so what I'm describing now is the is using the quill depth stop method. This in my instance, this is the adjustable part, and this is the fixed bit. So what you actually normally do is, and this is a quick release one of mine. You might have nuts that you've got to keep screwing it around forever. So this is a 10mm drill. So I'm going 10mm deep. We can put that in there, and just adjust it up until there we are. She's just pinched on that, and then what I'll do is I'll wind the table away from the part, release the clamp, and then the quill can come down until it hits the stop, and that's your 10mm. That is that method. Now if you haven't got a quill that moves up and down, which is extremely unlikely, but anyway, in case you haven't, we'll now describe a different method. Now in this setup, it's either a case of, if you can't move the quill, this is what you can use for either raising the knee or lowering the head. So what I've actually got now is some parallels and blocks. Any size you like to get it up within range you want. This is going to be my this is the Joe block of 10mm. So I've actually slipped it under the DTI, and then just a case of bringing this down until it reads, and then adjust it to read 0 or whatever. Right. You really need to say this is quite a flimsy setup. Really, you need something much more stable than this. But say, trying to find the parts for the demonstration. So of course, what you've now got is so that the cutter's on the top of the part, and you show it off. You want to go down 10mm. So all you actually do now is to remove this, and then raise the knee or lower your head until the DTI again reads 0. And coming up, are we just gonna catch on the body? Just need to move that a little bit. So this stylus only touching, and then just bring it up until read 0, and that's 10mm depth of cut. And I'll explain again before people say, oh, your stylus isn't in the right order and it's not square. It doesn't matter. We're just using it as a reference. It can be any angle you like, because you're just moving it until the needle reads 0. So you know, just like I'd mentioned that before people say, oh, you're not doing it right. We're just using it as an indicator. Well, I think that's probably about all that we can come up with, really. As I say, it's a real fiddly job to set it all up, but if you've got a job that needs doing, and it's got to be right, and well, you've just got to, as I say, just keep all this setting up to get the right dimensions. So if you haven't got a DRO and you know that your lead screws are worn non-linear, it's all that you can do. So it's just a comparison. That's all you're actually doing. Is you're just comparing where the position of the part is in one particular point, and then as I say, you either remove or you add your distance piece and get it back to 0 again. So it's just a comparison method. So I think we'll close this up here, and I'll go in and we'll talk about it as a closing matter. Join me inside later. Bye. So there we are. I hope you got something out of that and can understand my the way I was going about things. I mean, if not, you know, leave a comment and you know, we can hopefully sort you out. So thanks once again for watching. Thanks especially to all my new subscribers. So as per usual, please ring the bell, click the likes, send me a comment, and until we meet again on the next video, wherever you are in the world, please stay safe, well and happy. Bye.